also the same. Thanks. Sorry about that. I forgot to record. So we were discussing about the vector generation function. The first one we call a range, which similar to range function, where we can have start, stop, and step value. For example, in this one, when we say 1, 11, it will generate a number starting from 1 up to 11. That means we'll have 10 elements from 1 to 10. Right. And then the next function that we have just discussed is called linear space function. Linear spaces, how it works, in between two values, it will generate 50 linear space elements. So if when I say y equals np.linear space 1, 100, it will generate 50 elements in between 1 to 100. So a couple of things that you can do. For example, let's say I need 100 elements. Then we can change the values, the argument. The third argument, we can put it as 100. So this third one will indicate that how many elements that you need. So this can be read as, okay, I'm going to create a vector called set, which will create 100 elements between 1 and 100. Please note that all the numbers are floating point numbers. So you see this decimal point here, which indicates that they are floating point numbers. So in case if you want to convert into, let's say, integer values, so you can also use the data type we call D type as int, so which will create an integer vector which consists of 100 elements between 1 to 100. Okay. So after discussing about the vectors, we focus our discussion to creating matrices or two-dimensional arrays. So in numerical Python, like in lists, so the metric representation is basically a list of lists. So we know that list will be indicated using a square bracket. So now we have 3 by 3 matrix. The first row is 1, 2, 3. The second row we have 4, 5, 6. And the third row we have 7, 8, 9. So within the list, we have 3, right? So when you create like this, and when you say print A, it's nicely print as a matrix. So if you use shape, which we have learned earlier as well, when you say A.shape, it will tell us, okay, number of rows and columns. So it will be a 3 by 3 matrix. Okay, next few things that we have discussed, how to access element. I think these ideas we discussed with the list as well. The other thing that we have discussed is how to generate matrices. So there are a couple of methods available in numerical Python to create matrices. For example, if you want to create a vector or a matrix which fills with ones, the method we can use as ones, and you can give the dimension. So when you say ones 5, it will generate a vector which consists of 5 elements which filled with ones. If you say 3 by 3, it will create a 3 by 3 matrix which fills with number 1. Then we also discuss how to generate random numbers. So generation random numbers, there are a couple of functions we normally use. First two, you can generate random numbers using uniform random distribution, or you can also create random numbers based on the standard normal distribution. So based on that, you will use different methods. So if you want to get it from uniform random numbers, the method we call is np.random.rand 3, 3, which indicates the dimension. So you will get 3 by 3 random matrix. If you need an integer value, then we use randint, right? So these are the things that actually we have, discussed last time, right? So I think these are the things we discussed last time, isn't it? What was the last one you have taken? I think once the random matrices, we have finished our discussion, if I remember correct. So let me check. So last Wednesday, we had the previous one. I think, yes, this is the one we had. Okay, so we discuss up to, okay, random numbers. Okay, random integer we have not discussed. So let me start with that. Okay, so let's start today's session. Right? So in today's session, let's first look at how to create random numbers using integer values. So let me create a use of random integers. So the first one, let's say I'm going to create a, just a simple number. If you want to create a single number, so this is how we will use np.random rand int. This is the method we will have. If you use 1, 100, for example, the meaning of this is, okay, I need to generate random integer between 1 and 100. So let's put print d, and when you run it, I think we have to write import as well, because we are going to, this is the first time we are going to use. So this might gives an error because it doesn't remember what NP is. So let me start with that. So the first one should be import numpy as NP. Right, so now we are accessing the methods available in the numerical Python as NP, and we are using the method within np.random.randint, and we are getting a number between 1 and 100. By the way, if you have any questions, concerns, just type it in the chat. So time to time I can check and give you any answers, or you can simply raise your hands if you have a question. Right now, in this particular case, it says 70. Right. If you rerun, you will get a different value between 1 and 100. So it's you can see time to time, depend on how you run, you will get a number between 1 to 100. Okay, next one. Now let's say I want to create a vector. Now simply creation of a vector. Let me creating a vector. Simply I'm going to say np.random.randint. Okay, you can say 1, 100. So the first two numbers indicate the range. So the numbers will be between 1 and 100. And how many numbers you need, then you can put it as the next item. Let's say I need like 10 integers. So then I can just put 10 and if you print E, right? Right. So it will generate a random vector which consists of 10 random elements. Right. Generating matrix, I will discuss later on, because once you have the vector, we can convert a vector to a matrix, which I will discuss separately. Right. If you have finished up to this point, can you please raise your hand in your session? Like you can use reactions and you can raise your hands. Have you finished? May I move to the next one? So simply the idea that today's session, the very first idea we discussed, how to generate random integers, right? And we use method available in numerical Python, which comes under random and ran int. Desh and Vishaka. Finish? Okay, great. I think I can move on. Thanks, everyone. You can lower the hands. Okay, the next part, I would like to discuss accessing elements in a matrix. And the idea that I want to discuss is what we call slicing, which you can also use in list as well. We have not discussed this idea under list, but I think I can explain it here. So let me take a new code window. So I'm going to discuss, I'm going to first create a matrix. Now I'm going to create this manually, but later on I will discuss how to automatically generate a matrix like this. So in this matrix, I'm going to use NP array method. And within that, I will create a 4x4 matrix which filled with numbers from 1 to 16. So it's a boring one right now, what I'm going to do. But later on, we'll discuss how we can actually automate this. Right now, I'm going to have a list of list. So as the first row, I will put 1, 2, 3, 4. Then 5, 6, 7, 8, my second row. Then 9, 10, 11 and 12, third row. Then 13, 14, 15 and 16, my fourth row. So if you print x and if you say print x dot shape, you will see that we are getting a matrix. Right? 4x4 matrix which contains numbers from 1 to 16. Now, let's say you want to access any element, right? Within this matrix X, right? That's the idea that I want to discuss. So let's say, first of all, I want to access element in third row and fourth column. Right? So remember, it's very simple idea that I want to try. So I'm going to get X, and as a within a square bracket, I can list the index of X and Y. So I want to access the third row. So we know in Python index start with 0, 0, 1, 2. So that is 2, comma, column 0, 1, 2, 3. So fourth column is 3. So simply you can access third row and fourth column in this fashion by listing x 2, comma 3. So when you say 2, comma 3, it will access the element in third row and fourth column since Python start with index 0. So let's say I want to access whole third row. Simply we can put it like this. So let me say I want to access third row. I can simply say x. Okay, third row means 0, 1, 2, 2, comma. And to say that, okay, I want to access all the columns, we will use colon. So this colon indicate that, okay, this will represent all the columns from start to finish. So now let's say I want to access the fourth column. Can you tell me, you in the chat you can type. Let's say I want to access fourth column. Okay, can you tell me what should be my command in Python? I'm waiting your answer in the chat box. You can use the same ideas that we have discussed. The index start with 0. Yes, good. So the point here is when you say X, first you specify a row, then column. So in this particular case, we are accessing column. So to say that, okay, you need all the rows, we have column. And then we need fourth column. So since index is 0, we have 3. Right. Good point. Now let me ask another question. I want to get this middle 4 elements we call submatrices. So let's say I want to access 6, 7, 10, 11 as a submatrix. Can you give me the command in this fashion? I want to access the middle 4 elements. So let's say I want to access two by two matrix in the middle, like that which consists of 6, 7, 10, 11, right? How do you access it? So let me give you a hint. Now let's say I have an array called A. If I have, let's say 1, 2, 3, 4, 5, 6, 7, 8. If I need like, let's say middle 4 elements, right? You can simply say, okay, print A. And then here we have only row. So this is 0, this is 1. You start with 2. So you can say 2 colon, then 2, 3, 4, 5. That means up to 6. So if I do like that, yes, we will get 3, 4, 5, 6. So this is called slicing, right? Which means you can actually take the middle point. Now, when you just say colon, it indicates start and stop. Starting value to ending value. Now, when you have in between, it's similar to start and stop. So you indicate the starting value and the end value, but remember, it should be, one item less than the number. So when I say 2 colon 6, so it will indicate 2, 3, 4, 5 index numbers. So now my question is, like, we have matrix X. I need these middle 4 elements. So first of all, I have to specify row values. So the starting value is 2. Then 3 goes up to 4, right? So that means you start with a 0, right? 1, 2, right? So we have to say print X 1 to 3, right? When I say 1 to 3, it's indicate 1 and 2, comma, column also 1 and 1, 3. So 1 and 2. So if you do like this, now you can see you will get the middle 4 elements. Exactly. So I see Vishaka has figured that out. So this is a very important idea which we will use. For example, in data set, sometimes we need a subset, right? So
is that Digala?
Yeah.
Is that 3 or 2? Middle. 0, 1, 2.
It should be like this, right? Now, normally, these two numbers indicate, similar to our earlier ideas, start and stop. So when I say start and stop, if you want to go from 1 to 10, we will type 1 and 11.
Okay. Right. Thank you.
Same notation. So when I say
Thank
1 colon 3, it indicates 1 and 2. So it goes up to 3, right? Not including 3.
Thank you. I got it.
Right. Now let me go back, because my next idea is about the submatrices, right? Submatrix. So let me print X. So it's a 4 by 4 matrix. And then let's take, right, Y. And I'm going to say it's the submatrix. I'm going to get it from 3, comma. So you know what Y is now. If I finish up to this point, you can raise your hands. Then I'm going to discuss the view of, as well as, change of values. So whether you need a copy of the submatrix or whether you need a view of a submatrix. Once you finish up to this part, please raise your hands. Okay, thanks everyone. So now I have an important question. Now let's say we have a matrix X, which is a 4 by 4 matrix. You can think it as a larger data set. Then I get a part of that data as Y. So you can see you have a take a subset of the data set. Now let's say I'm going to make all the elements of Y as 0, right? This is what I'm going to do. So what I'm going to do right now is I'm going to make all the elements. When I say all the elements, this is how I'm going to make it. You understand the notation now. All the rows and all the columns, I will assign it to 0. So now when I say print Y, right? Y becomes 0. I hope you understand what I did. So originally I had a 4 by 4 matrix of X. Then I have taken a part of it as Y. Then I made all the elements in matrix Y as 0. Now my question is, if I say print X, is it the same as previous one or is it different? Or my question is whether anything is happened to X. Is there an effect when we set all the values of Y as 0?
Same X.
So I will explain one more time, right? Now, originally we had the matrix X and part of it we have taken as Y. Now we make all the elements set to 0. It's a very important question, especially different programming languages treated differently. So I want to discuss this idea of in Python as well. Okay, let me simplify this question. Right, I'm going to take two lists. I'm going to forget about this numerical Python arrays. I'm going to take two lists. I'm going to say first list A is 1, 2, 3, 4, 5. Then I'm going to say B equals A. Now I'm going to say B is 0. I'm going to put 10. So when I say print B, right, I'm getting this. My question is, when I print A, what will be the outcome? If you can answer this, it will be the same answer for the previous one as well.
A does not change, I think.
Now we had originally A with 1, 2, 3, 4, 5. Then we said B equals A. And we change B now, part of B. My question is, what will happen to A? So to understand this idea, remember, in Python, we can simplify this like this. Let's say in Python, we are going to tell something like this, right? So let's say we have A equals 10. So in memory, what will happen, right? It allocates a space to hold the number 10. and the memory reference A will indicate the memory reference. When we say B equals A, it will not, in Python, it will not create a separate memory location. But since A is equal to B, B will also indicate the same memory reference. Right? So when you say a same memory reference, when you change something in B, it will change something in A as well. Right? So because of this reason, when you say print A, it has affected A as well. Right? So now I can go back. Now, when you take a subset like this, we have a matrix X and we take a part of as Y, and when you change the elements in Y, it will affect A as well. When you say print X, you will notice that the middle 4 elements replace with 0. So this is called view of. So when you take a copy of this, right, this is called view, a view of origin matrix. So this assignment will give you a submatrix and it will a view of the original matrix. When I say view of the original matrix, right, when you make some changes into this matrix, it will affect the original as well. Right? So here we can say Y is a view of X. That's why when you change Y, it will affect X as well. Now let me give you an answer for this. Let's say you need a copy. So let's say when you make something change to Y, you don't need to change X. So yes, let's say, okay, you need a copy, not a view, right? And this is how you should get it, right? So I have to start from the beginning because I have replaced the values. So I'm going to start from the beginning. I will redefine what X is. So I'm going to make it X again. And let's say when you want to get a view of X, when you say 1, 3 and 1, 3, this will give you a view. So if you need a copy, you have to use a copy method. So with this, what happens? We can say here, Y is a copy of X. So when you say print Y, so now you can see it's the same as earlier. It'll give you middle 4 elements. So let's change the value of Y to 0 and let's print Y and let's print X. So if you do like this, you will notice that, right, it won't affect the value of X because you are getting Y is now a copy of X. So I have seen like some of you are already familiar with the idea, and that's great because some of you might have the difficulty understanding this one. Okay, if you have understood and if you have finished up to this point, please raise your hands, then I'll move to the next one. So what we have discussed here is getting a view of a matrix and getting a copy of a matrix, the difference.
So,
Yes, finished?
so when you make the copy of X, when you make the copy function, in the memory, there's a separate location for that matrix, right?
Yes.
Submatrix.
Yes, you can in Python, you have a method called ID method, which you can actually check the ID. So for example, if you check the ID for X and Y, it should give two different values. In case if it is the same view, then it should give the same value.
Thank you.
Right. Thanks for asking questions. And you can lower the hands. Right. Next, I'm going to check like how do you check the values in a vector or matrix. Let's put some conditions. So this is known as fancy indexing or sometimes Boolean valued indexing. And usually we use in MATLAB as well. So the idea of this is sometimes in a data, you want to check some conditions, right? So let's, the idea that we are going to discuss is called fancy indexing. Or sometimes we call Boolean indexing. Right? So idea is something like that. Like to explain this idea, I will create a vector which consists of numbers from 1 to between 0 to 1, right? So I'm going to use linspace method. This will generate numbers, linear spaced value between the two values. So for example, when you say 0, 1, this will generate 50 elements. So let's say I need like 11 elements. The reason is obvious. So when you say print A, you will see what will happen. So here you will see I'm generating 11 values up to 0 to 1 with the difference of 0.1. Right. Now let's say I want to check whether the values are greater than 0.5, right? So within this, so let's say we want to check, right? The values are greater than 5. Simply, you can have this by just saying, you can simply ask A greater than 0.5. So when you write this, this means it will go through each and every instance and check the values. So let me first print A as well, so you can compare. So we have, you can see 0 is not greater than 0.5. So we are getting false, 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 false. And this is also false. And then these will be true, 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 true. You have like this. So let's say I want to get only that value. Since now we have this, the index, whether it's true or false, the trick that we can use is simply we can have A, instead of index, we can put this condition. So we can have simply have the inequality. When you put it in this form, simply we are going to get the indexes, whether it's true or false, whether the values are greater than 0.5. And that will retrieve the only value greater than 0.5. So this will indicate, right? So this is a simple trick that we will use sometimes when you want to filter out values in a vector or a matrix. And the idea is known as fancy indexing. Right. Okay. Good. Okay, those who have finished, you can try the next one. A small question. Generate. Now you know different ways of generating numbers, right? So generate, number vector. Okay. Those who have finished, you can try this. I want you to generate a vector which consists of numbers 1 to 16 using a range function. The range start from array range. So you can use start and stop to generate numbers from 1 to 16. Yes, you can share me the answer in the chat. We have already, you can even use linear space function if you want. We have discussed two methods to generate vectors and, especially vectors. Yes, let me say this is, thanks Vishaka, shared an answer. How about the others? You have to specify only start and stop value, right? Because step is 1. So simply we can have 1 to 16. Yes, the format. Let me say, okay, I'm going to create a matrix later on. So let me put it as a capital A, np.a range. What is the start value and what is the stop value? So that was the question. Right? Remember, a range function, we have a start, stop, and step. Start will specify the starting value. We need 1 as a starting point. The stop value, the value should goes up to that number, not including that number. So we want to go up to 70, not including 70. So you can put 1 and 17. So when you say print A, yes, this will generate a vector which consists of 16 numbers, right? 1 to 16. Okay, now remember that I have discussed, we have created a vector called X, which is a 4 by 4 matrix. So now once you have the vector, we can convert this to a matrix by reshaping. So put a dot here and use a reshape method. So reshape, and you can tell exactly the dimensions. So if you need like 4 by 4, we can say 4 by 4. So what happens now? So you create a vector with numbers from 1 to 16, then you make it a matrix by reshaping this, right? So this will produce 4x4 matrix. Remember, I discussed that you can actually automate our 4x4 matrix earlier, and this is how you should be doing. So you can use a vector generation function to generate a vector, then you convert into a matrix.
So, sir,
Yes.
sir, when we are reshaping to a certain dimension, how can we know like to what dimension we can reshape this vector? Like we can't, can we reshape to any sizes or like to some sizes? I think sometimes we can't turn it.
Yes, exactly, Vishaka. I mean, you should know the dimensions. Like in this particular case, we have 16 elements and 4x4, which creates 16 elements. The dimension should match. Was it your question or is it like some?
Yes, sir, thank you, sir. No, I mean in some cases I I don't know like to what shape I can.
Transform into? Okay, so the reshape function usually we use when we know ahead the dimension. So simply this will be a technique that you can use to generate matrices, right? Once you have this, sometimes you have to reshape. Now, for example, now in this particular case, we make a matrix. Similarly, you can change it to a vector, right? So for example, if you have a set of images are matrices. So let's say you want to have like a set of images when you want to have it in a 2D form. So reshape might be useful.
Thank you so much.
Yeah, Digal,
Yeah,
so I think it is 16, so we can go for 2x8 or 8x2 also, huh?
exactly, sir. So
thank you.
for example, yeah, just try, I mean, change numbers, but make sure that the dimensions are matched.
Yeah, thank you.
Right. The next one, I would like to discuss matrix concatenation, the ideas we can use to later on. For example, when you are going to combine two data sets together. So simply you can think it as like concatenating matrices as well. Or maybe you can think it as like combining two images, right? So we are going to look at how we could concatenate matrices. Right, so let's move to the next part. And this is the last one I'm going to discuss under this. Then I will discuss matrix operations, which you should be useful for you when you're manipulating matrices, right? So let's start with the matrix concatenation. Now, when you say a concatenating matrices you need, so you can, let's say concatenating matrices. So let's say I have, four matrices. Let's say first matrix A. You can manually create if you want, or now you know how to create automatically as well. So in this particular case, I'm going to create a couple of 3x3 matrices. Yeah. And let's say B. or you can generate some two arbitrary matrices. Perfectly all right, because you now know different methods of creating matrices. So, but A, B, like two matrices. Now, one thing is we want to get the help of these methods. For example, the method that I'm going to use is called concatenate. So hopefully this should give us what will happen. So concatenate means join sequence of arrays along an existing axis. Okay, so you can have any number of matrices. Right now we are only using two, right? But remember, when you're concatenating, usually you have to put it as a tuple. That's what this help tells you, right? And for my case, if you want to make it in row wise, right now, this is, let me print A, then let's print B. So A is like this, B is like this. So when you want to combine row wise, we can say, okay, I'm going to use print np.concatenate. We have to say comma B. Note that you have to put it as a tuple. Otherwise, you might not get the final answer. So this will give you sorry, it should be capital A and capital B. So I was wondering why we got this answer. Right. So this will generate, yes, row wise, which means 6x3 matrix. So this is A and this is B. So it'll combine as a row wise. So now by going through the help, can you tell me how I can combine these two, right? Column wise. Finished? If I finish, please raise your hand, then I'll move on to the next one. I will explain how you combine column wise. Okay, thanks everyone. So the next one is go through this help function. Always remember, when you want to know more about any function, you can just type the module name dot the method name. So you see that when you use axis, the axis along the arrays will be joined. If axis is none, arrays are flattened before use. The default is 0, right? So in this particular case, when you say axis 0, that means it's row wise. So if you want column wise, only addition is make axis to 1. So let's take another code window. I will take this and then I'll put A comma B here, then comma axis, I will make it to 1. So which now combine this column wise. So you see here we have A, this is A, and this part will be B, right? So this will be A. So this is A. Right? And this is B. So it will concatenate, right? Column wise.
Can I ask one question?
Yes, yes.
How program remember now this two results?
Okay,
So
now
only
right
print.
now, sir, I mean, I didn't put to anyone since I just use print function. So the only method is you have to use some variables. You have to assign the answer. So it's not like in MATLAB where it automatically create answers. So here you have to specifically say, okay, how to store them.
So it need another command line. No?
Yes, you have to create another variable and you have to store it there.
Right. Thank you.
Okay, I think with this one, we finished the first part of this matrix handling. We know how to manipulate them. We know how to generate them, right? The next part, I would like to discuss some matrix operation. And finally, I'm going to discuss some linear algebra equation solving, plus maybe solving polynomials. With that, I would like to conclude. So let's start the next part then. I hope everybody is finished. If not, please let me know. If I'm going fast, let me know. Right. So the next part, right, I'm going to delete this. So let me create a text. So I'm going to create matrix operations. So when you talk about the matrix operations, I'm just going to type it. It's not that difficult. First one, transpose. So let's say we have a matrix A with 1, 2, 3, 4. Simply 4 by 4, 2 by 2 matrix. If you need transpose, you can use A dot capital T, which indicates the transpose of A. So the matrix A is 1, 2, 3, 4, but when you say transpose, we get 1, 3, 2, 4. Next one. I want to discuss operations between matrix elements. Or in other words, elementary functions. Just indicate if you finish the transpose, you can raise your hands, then I can discuss.
So for transpose, it's like MATLAB, B equal AT.
Exactly. Yeah.
B equal AT, A dot T.
Yes. Dot T will indicate, dot capital T will indicate that it's a transpose of A.
A. All right. Thank you.
Right. The next one. Let's create two matrices and we'll work on elementary wise operations. Sometimes in MATLAB we use dot operations, if you remember. So in this particular case, let's say we have A. I'm going to create a matrix. Let's say the same way, 1, 2, and then we have 3, 4. And let's say matrix B. right? So we have two matrices. Now, simply, if you want to add element-wise addition, simply the command is, we can say np dot add, we can say a comma b, which will add each element together. So originally A we have 1, 2, 3, 4, and B we have 5, 6, 7, 8. Element wise addition, we'll get 6, 8, 10, 12. Similarly, you can go for subtract, multiply, and divide. So let me put them as well. Print np dot subtract a comma b. So you can see now it'll be -4 for all the element, because 1 minus 3, 2 minus 4, 5 minus 7, and 6 minus 8. Similarly, you can go for np dot multiply. So all these will be element-wise operations. If it needs a matrix multiplication, it's a dot operation. There's a method called dot method where you can actually perform a vector operation. So for example, so this is element-wise operation. This is element-wise operation. As the last one, so the matrix operation, let's say matrix multiplication. So you have to use np dot, and maybe we can say a comma b, which is the matrix multiplication. You'll see we are getting 19, 22, and 43 and 50 because it's the matrix multiplication. So the first four methods, they works on elementary wise, element by element operations, whereas the second one, the last item, we did the matrix multiplication. Okay, if you are finished, please indicate by raising your hands. Then I'll move to the next part where we are going to discuss how you may get mean summation as a product of elements in a matrix. Right, thanks everyone. So let's move on getting average. So getting mean values. First of all, let me start with the vector. Let me say we have vector v, np.array. Let's say we have, 4 numbers, 1, 2, 3, 4. And simply, if you let's print v and then mean value. We can say np.mean and v. And this is the method that we normally use to get average value. So the total will be 10 divided by 4, you will get 2.5. Right. Now let's create a matrix A. Let's create a matrix. I'm going to create a 3 by 3 matrix. Let's print A, and let's print np.mean A. So simply it's same as previous one. It get the total of all the 9 numbers and divide by 9, which is 5 is the average. Right. Now, if this is like a data set, sometimes we are interested to get mean, row-wise mean, as well as column-wise mean, depend on our requirement. So remember, we use the value axis. The default axis we have seen is 0, which means you will get row-wise mean. So let's take row-wise mean. So let's say np.mean a comma axis equals 0. So meaning of this is mean row-wise. So you can see now the mean will be 4, 5, 6 because you add 7, 4, 1, divide by 3, 8, 5, 2, add 15, divide by 3, 9, 6, 3, you divide by 3, you will get 4, 5, 6. Similarly, if you need column-wise, then use np.mean axis as 1. So this is mean column-wise. So when you say mean column-wise, yes, you add 1, 2, 3, divide by 3, you will get 2, 5, and 8. You will get 2, 5, and 8. Okay. So that's how you can get average or the mean values. So we discussed when you just use mean, it will calculate all the elements and get the average value. And if you use axis, then with axis, you can define whether you need the mean value or average value in row-wise or column-wise. Similarly, instead of mean, use sum. Will give you the sum of the numbers. If you need the product of numbers, use product, prod. Yes, try with, yes, instead of, if you use sum to get sum of numbers, use prod for product of numbers. So instead of mean, just replace mean with sum and prod and observe that you can get the summation. You can get sum of the element in row-wise, column-wise. You can get the product of the whole matrix A, or you can get the product row-wise and column-wise. Once you finish all these 3, you can raise your hands. So then I'll switch to discuss equation solving in numerical Python. Hope you guys are finished by now. You can lower the hands. Thanks. Right, next part. I would like to discuss few ideas which might be useful for you, especially when you want to like linear algebraic functions. So the simplest one that I can use is equation solver. Now let's say we have two equations. Let's assume we have x1 plus 2x equal 10 and x1 minus x2 equals 7. So the first point here is we'll convert these two equations is to vector matrix representation with the coefficient will be matrix A and then x, that means x1 and x2 equal b4. So assuming that you have the x equal b4, you can represent what A is, what B is. The equation solving is the use of linear algebra. So in numerical Python linear algebra, you have a lot of methods. So just try help. You can get more details about like what methods available. So for example, in this particular case, if I go back, right, you can show help. And then you can, look for linear algebra. So when you use numerical Python and linear algebra, so you can see what methods are available. So in my case, I just type linear algebra. Let me go to the top. So this is the help where you can see there are a lot of methods available within this. So you can go through and see whether you have necessary methodology available under this library, right? So this is linear algebra. So NumPy linear algebra functions, right? And you have a whole list of operations supported and also the methods. Now, particularly we are going to discuss with the solve method. So I'm going to just type solve. So if I say solve, so in solve method, it will give you help on only the solve method under linear algebra. So here is when we have equation solver. So we see here it solve a linear matrix equation, exact solution x well determined, that is full rank linear matrix of Ax equal B. So we have to define what an AB is, then you can use solve method to get the answer. So let me explain. So in my previous example, I'm going to use the same example. We have coefficients 1, 2, 1, minus 1. And then we have a B, 10 and 7. So let's put that here. Right. So I'm going to remove this for the time being. You know how to get help now. So the first is we have to make it a form of linear equation form of Ax equal B. So let's define what A is as a NumPy array. We say NumNP array. And this will be a matrix where we have the coefficients. We have 1, 2, and then comma 1, minus 1. So this is the coefficients for A, and B, we have array. It's an column vector. So we have to put as 10 in the first row and 7 is the second row. So the solving method is, let's say the answers are X. We say NP dot linear algebra dot solve method. And within that we have A comma B. So then finally we get what the values of X are. So you can see, so this will solve the two equation in the matrix 4. And the value of X are 8 and 1. So you can try some more examples where we can represent in this form. Right, if you finish this, please raise your hands and I will discuss the last one for today. That is how we can, get the roots of polynomials. So with that, I will conclude today's session. Okay, we have Vishaka finished. How about the others? Okay, thanks everyone. Let's move on to the last part of today's session. So let me first share the note. I have already shared the note. I hope you all received this. Please go through so all these because some of the things I have not gone into details. There are some of the things that you could even try as well. Right. So as the last part of today's session, I would like to discuss, how to get the roots of a polynomial function. Let's say we have a polynomial equation in the form of pxn, pxn minus 1 and up to pn in this form. And let's say we want to get the roots of a polynomial. So we know that when we say roots of a polynomial, we will expect to get the values of the variable for the polynomial is equal to 0. So that we have to actually solve for this. So in numerical Python, there's a function called root function, which we can use to get the roots of a polynomial. And the other point is you have to get the polynomial as a vector, at the vector of coefficients. Now let's assume that our example, we have a polynomial P1, which is x to the power 3 plus 2x minus 7. So the first one is we represent P1 as a vector with the coefficients. So the coefficient of x to the power 3 is 1. We don't have a value for x to the power 2, that is coefficient will be 0. Then x to the power 1, we have the coefficient 2, then minus 7. And simply, when you use np.roots p1, you will get the roots of polynomial. So obviously, when you try this will be a complex roots. If you're not that familiar, just forget about this. But for the time being, the roots are in this form. Maybe I can give you a easy one. Let's say we have roots are 1 and 3. So if you have 1 and 3 roots, we know then it's x squared minus 4x plus 3, right? So you can try that. So let me show you this. So let's start. I will take this separately. So let's say we have a code. And let's say we have roots of, let's say, x minus 1 into x minus 3. You see, I'm going to go from the other one just to have a simple one. So we will have x squared minus 4x plus 3. So let's say this is my polynomial. The trick that I have to use is I have to define polynomial, let's say p as the coefficient. So we have 1 minus, okay, we can have 1. Obviously, you can have it as a numerical Python array. So we have main p array. So within that, we can have coefficients. We have 1, we can have minus 4, and then 3, right? And the roots is then we can say print np dot roots, and then we have say p. So which should give us yes, we have 3 and 1. So you know that now we took a easy one instead of the example in the note, right? So this is called getting the roots. And the other one is if you know the root, you can get the polynomial back. So that's the second one. So this is like, right, finding roots. So here we find roots of a polynomial. So the equation is we have x squared. Let me put in this 4 minus 4x plus 3. So that's what we took. So I can go other way around as well. The second one is given roots. Given roots, we can reconstruct the polynomial. So it's like this now. The command is, it's called poly, and you can give it as roots. So let's say our roots are, we have 3, 1, 3. And then when you run it, it says 1 minus 4 minus 3, which is the coefficients that we have, right? So you can reconstruct the polynomial if you know the roots. For example, if you have 1 and 2, let me change 1 to 2. So that means x minus 1 and x minus 2. Yes, we get x squared minus 3x plus 2, right? So you can reconstruct when you know the rules. The third one that I would like to discuss is the last one. So given a polynomial, let's say we want to find a value, right? Now we know the polynomial of this is x squared minus 4x plus 3. When x is 0, we know the value of the polynomial is 3. Let's say we need to find out. So for that, we have this. So for example, if you want to calculate the value of the polynomial at x equals 0, this is how we should be doing. We can use print np dot, it's called polyval, and we can have the polynomial, what the polynomial that is p, and then let's say the value is 0. So if you put in this form, you should be getting the value, right? So you should be getting 3 here. So which is the correct answer. Right. Okay, with that one, I think I have gone to a bit depth in numerical Python compared to a simple tutorial, which I think will help us to understand the machine learning implementation, especially when we work with our data sets, especially when we manipulate our data. So to summarize what we discussed in today's session, we continue discussion of how we can generate vectors and matrices, and also like how to manipulate them, right? And finally, also we discuss some of the basic commands available in matrix manipulation, and also some equation solvers and polynomial solvers. With that said, I'm going to finish today's session. Thanks everyone for attending this, and also like answering my questions and posing questions. I hope this will be very helpful, especially this piece of tutorial is helpful those who actually wants to convert MATLAB into Python, NumPy, because NumPy is the module mostly used to convert like your MATLAB code into Python. Right. Now, having said that, let me give you my plan for the next session. Next session, we are going to look at the visualization. Then once we finish the visualization part, we will look at pandas, which we work with the data sets. And then we are going to implement machine learning models. So within another 3 or 4 sessions, hopefully we can write a complete code in machine learning, starting with data sets to training a machine learning model. Okay, with that, I will conclude, but this is open for any questions, comments, concerns you might have. If I'm going very fast, please let me know. And if I'm going too slow, also please let me know. But I hope you enjoyed the session. Right. Thanks then. We'll meet on Wednesday then again. Hopefully physically, because today I work from home. So I'll be there tomorrow and day after tomorrow, so we can meet and we can have a physical session as well. Thank you, everyone.